Okay, so distributive law in set theory, I can show it this way. The law is A intersection B union C is same as A intersection B union A intersection C, right? So I will show it this way using Venn diagram. A intersection B. See, this is A intersection B, right? This is A intersection B. And you want to combine this with A intersection C. So this is the region A intersection C. So if you want A intersection B union A intersection C, this is how the region looks like. Okay, so this is, I'm making right hand side. We can now come under this and we can create the left hand side. So you can prove this using truth table also. You can show it using Venn diagram also. That's the beauty of this chapter, that you can always relate this to set theory. Okay, the above statements can be proved using logical the truth tables, and if you write it in the set theory format, you can use Venn diagrams to prove it. Okay, so this is how again we are going to create circles. We have A, B, C as 3 sets, and what I can do is I want is A intersection B union C. So this is B union C, right? So we have B union C, and I want to find out its intersection with A. So the horizontal lines is A, right? So where you can see the intersection of both the horizontal and the vertical lines, obviously in this region here. So this is what is the left hand side. Now you can see the region here is A intersection B union C is same as the region here. Okay, so that is how we can in set theory also prove the statement left hand side is equal to right hand side. That is distributive law. In distributive law, what we do is we distribute the statement inside. So this is P and distributed inside, it becomes P and Q or P and R. Okay. Okay. In distributive law, also one more thing is to remember is both these are different, and or. And in associative law, if you remember, both these signs are same, or and both are same. Okay. The next law is complement law. Complement law is P and negation P is always contradiction, right? We can make truth table to prove it. P negation P, P and negation P. If P is true, negation P is going to be false. If P is false, negation P is going to be true. And then when I say true and false, I get false. Here when I try to find out false and true, I get false again. So if P is true, negation P is going to be false and is false. If P is false, negation P is going to be true. Again, you find out P and negation P, you're going to get false. So P and negation P is always false. So always false statement is called as contradiction. Okay. So if you want to write the dual of this, then if you are writing the dual of this statement, the dual of this statement will be P or negation P is P or negation P is tautology. P and negation P is contradiction. P or negation P is tautology. While writing the dual, and becomes or becomes and, tautology becomes contradiction, contradiction becomes tautology. Right? We just discussed in the previous video. So that is how the dual will help you to get the statements without using truth table. First statement we can show using truth table. The second we can do it directly using the dual. Okay. The next law which we are going to do is called as identity law. In identity law, we say P and tautology is logically equivalent to P. We can make the truth table for it. P, tautology, P and tautology, right? So P, tautology, P and tautology. This is true. This can be false. Tautology is always true. So when you're finding true and true, it's true. But when you're finding false and true, it's false. We just discussed this in the previous video while I was explaining dual to you, that P and tautology is P, right? The dual will be P or contradiction is P. Okay, there is one more set here, that is P and contradiction is contradiction, right? P and contradiction is contradiction. Very simple. P and contradiction is contradiction. Very simple it is. This is true. This can be true. This can be false. Contradiction is always false. Then you have true and false, false. False and false, false. So in P and contradiction, the result is always false. P is true, then also P and contradiction is false. If P is false, then also it is false. So true and false is false, false and false is false. In and, if one is false, the answer is going to be false. So it is independent of P now. If P is true, then also it is false. If P is false, then also it is false. So P and contradiction is false. And the dual will be, yes, it will be P or tautology is always tautology. That's a dual, right? How it works, how the dual works, you know, and becomes or becomes and, tautology becomes contradiction, contradiction becomes tautology. True or true is true. False or true will also be true. If P is true, obviously in or, in disjunction, this is always true. Then independent of P, you can write the result as true always, because this doesn't matter now anymore. T is tautology, which is always true. So if P is true, you get true or true, true. If P is false, you get false or true as true. Okay, that is called as identity law. We can use this in the set theory also. We can show it by set theory. A intersection A dash is a null set. We can say A union A dash is the universal set. It's the universal set. Okay. These laws also can be shown using set theory notations. So how this works? We can write down A intersection null set is a null set, right? And then we can say A union the universal set. I'll call that a sample space. A union the universal set, A union the sample space is obviously the sample space. So A intersection null set is a null set. A union sample space is a sample space, right? That's how it works. Okay. So here also we can say this is a sample space, right? See what happens is there is a and this outside region is A dash. When you try to find out the intersection, it is a null set. When you try to combine, you get the entire sample space. Okay, so that is how it is going to work. Complement law, identity law. I hope it is clear to you. The next law is involution law. Very simple. Involution law is nothing much. It is negation of negation P is going to give you P. negation of tautology is equivalent to contradiction, negation of contradiction is equivalent to tautology. It's very simple, straightforward. Involution law. Conditional law also we have covered previously. So P implies Q is negation P or Q, right? We have covered this previously. So P double implies Q will be P implies Q and Q implies P. That is going to be logically equivalent to negation P or Q and negation Q or P. So P implies Q is negation P or Q. Okay, we have done this previously. Next is De Morgan's law. So conditional law is, we have done this previously. P implies Q is negation P or Q. P double implies Q is P implies Q, and in written Q implies P, and then you write the equivalent form of it. De Morgan's law also we have done previously. That is negation of P and Q is logically equivalent to negation P or negation Q. Negation of P or Q is logically equivalent to negation P and negation Q. So and becomes or becomes and then the negation moves inside. That is what the De Morgan's law is. Okay, so very quickly we have done these laws because they are quite simple. So involution law says that it is negation of negation P is P, negation of tautology is contradiction, negation of contradiction is tautology. The conditional law is P implies Q is negation P or Q. P double implies Q, you can see it is P, and P implies Q and Q implies P. And De Morgan's law, the negation goes inside. Very quickly we have done these laws, and these are easy, we have already covered them before. The last law which we are going to go through is absorption law. Now in absorption law we have the statement as P and P or Q. Now looking at this law, we get a feeling that why shouldn't we use distributive law? Let us use the distributive law. So when I use distributive law, what I do is I say, see, inside and outside the signs are different. So I say it is P and P or P and Q, right? Now P and P is by idempotent law P, idempotent law, right? First I used which law? Distributive law, right? First I used distributive law. I have distributed P and inside, so P and P or P and Q, and once I do that, P and P becomes P, idempotent law, the first law, and I get this P or P and Q. Nothing much, still having the similar result. Okay, I further try to apply distributive law. Again, the signs inside and outside are different, so we get P or P, right? It goes inside P or P, and again we have P or Q. And if you want to find out what is this going to be, P or P by idempotent law is again P. P or P is P, idempotent law, it's P again. And we have P or Q. So we have got the same result. See, P and P or Q, P and P or Q, same result, right? So if you see, first I applied the distributive law, P and P or Q, it gets P and P or P and Q, P and P is P, or we have P and Q now. Similar to first only, again we apply the distributive law and the idempotent law, we get back the same thing. So it's just like we are in a catch-22 situation, and we are not able to simplify or find out the simple form for this statement. That can be achieved only by truth table. So let me explain you by truth table what I'm trying to tell you. So by truth table, we have to first find out P. Okay, now let us make a truth table, not in the HSC format. Let us make the truth table now in the CD format. Now in CD, how are we going to make the truth table? See how it works. You can take P as true, true, false, false. P is true, true, false, false. In HSC, we write it in the vertical column. What I'm asking you to do here is you write all the truth values in horizontal format only. Don't use vertical column, write in the horizontal way. And remember the standard results, like standard results for P and Q. P and Q, the truth values will be true, false, false, false. I repeat, it will be true and false, false, false. Right? If you see the truth table of P and Q, you'll realize that in P or Q, it is first three are true and the last one is false. When both are false, it is false, right? So it is true, 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 false. Right? What I'm asking you to do is you can remember the results for P and Q. P and Q is true, false. True only when both are true, in all the other cases false. P or Q, you can write it as true for everything except the last one, where you can say it is false when both are false. P implies Q, it is true, false, true, true. You have to remember this sequence to solve it quickly in CET. P double implies Q is true, false, false, and true again. You can see the truth table, you'll get this sequence there. Okay, so we come back to the truth table here. What I want to do is I want to find out the absorption law by truth table, what it is going to be. So P and P or Q. So what I am written down is truth values of P: true, true, false, false. P or Q. P or Q is, it is true in majority cases, only false in the last case where both are false. And then one by one we can find out the and now. So true and true, it's true, right? Then we have true and true, again it is true. Now it is false. False and, I don't have to see here what it is going to be false only, because in and, if one is false, the answer is false, but still it is false and true. False, false, and false, false. So I realized that I'm getting back the P. See the truth values of P: true, true, false, false. See after the operation, what are the truth values? True, true, false, false. So after the operation, I can say this is giving the result same as P. So P and P or Q is logically equivalent to P. Right? So what is the statement coming out to be? P and P or Q. We can say P is in majority. It's logically equivalent to P. That's how we can remember. If you want to write the dual, P. If you get Q outside, if you get Q and Q or P, Q and Q or P, it is Q. It's that way. So if Q is in majority, the answer will be Q. Right? Okay. Yes. So that is the absorption law. Okay. So quickly, let us just take a look back. We can look at all the laws again, and then we can start using it to solve the examples. Okay, so I'm starting with the idempotent law. Let us revise. Idempotent law is very simple. P and P is P, P or P is P, and it can be converted to the laws. All the laws here can be converted to the laws in set theory, and all the laws can be proved by using truth table or by using set theory Venn diagrams. Right? So commutative law, next is P and Q is Q and P, you can switch the sides, that's commutative law. Associative law, अंदर बार दोनों signs जो है वो same रहेगा, and you can first associate Q with P, then you associate Q with R, the result will remain the same. Distributive law, in distributive law what happens is P and Q or R, अंदर बार signs अलग रहेगा, and then you distribute P and inside, so we get P and Q or P and R. Up there it is P or Q and R. So outside we have or, so it becomes P or Q and P or R. Then we have A intersection B union C. Converted to set theory, I then proved using Venn diagrams. So distributive law अंदर बार signs अलग रहेगा, then you distribute at that time. Complement law is important. P and intersection P is P and intersection with negation P. Okay, so P and negation P is contradiction, P or negation P is tautology. Identity law, P and tautology is P, dual is P or contradiction is P. Then we have P and contradiction is contradiction, P and P or tautology is tautology. Okay, those are the four laws. Identity law. Then we have involution, very simple. Negation of negation P is P, negation of tautology contradiction, negation of contradiction is tautology. Conditional law we have done previously. De Morgan's law we have done before. Then we have absorption law. Absorption law, first I tried using distributive law, I'm getting the same answer. Then I showed you using truth table, we got down to as P, and I said you can now make truth tables in the horizontal manner like this, and that can be helpful in CET, and these are the results which you can remember to do it quickly. Okay, so these are 10 laws which you'll be needing to solve the problems henceforth. So you have to quickly note these down and revise before starting with the sums. Okay, so now I'm going to start with the sum. The next is the first sum which I have written over here is P and Q or negation P. I want to simplify this. I can always use, let me remind you, I can always use truth table to find out what the answer will be. You can always use truth table to find out the answer, but we are going to use laws here. So how this works, P and Q or negation P. Identify, अंदर बाहर signs अलग है, right? So I will write it down as P and Q. That's logically equivalent to P and Q, or it is P and negation P. What is this law? This law which we have used here is distributive law. Okay, so you'll have to write this at the side like this, distributive law in HEC. Okay, so again I repeat, what is the law which I have used here? P and Q, this is distributed inside, P and is distributed inside, it becomes P and Q or P and negation P. So I have used distributive law. Write down the laws at the side. The next, P and Q, nothing we can do, but yes, there is a situation here, and what can we do is we can say P is ANDed with its complement. So what law we can use here? We can use by complement law. So I'm going to write down by complement law, I'm going to write down P and negation P as contradiction. True and false. False. If this is false, then you have false and true, still false, right? And always remember, after applying the complement law, you will have to use identity law, right? What was identity law? Identity law is if you have a statement A, so A and tautology. A and tautology is A. If you write a dual of it, it is A or contradiction becoming A. A and tautology is A. A or contradiction is A. in identity law, right? Then there are two more statements. A or tautology is always true. A and contradiction is always contradiction. It's false. Right? Okay. So in this scenario, we are going to use the one over here, the second one. A or contradiction is A. So P and Q or contradiction is P and Q. So that's the simplified version, right? So this is the entire sum in front of you. We have to simplify P and Q or negation P. So what I do is I distribute P and inside, and what I get is P and Q, or I get P and negation P. P and negation P is contradiction. So we have P and Q or C. P and Q or contradiction is P and Q by identity law. Okay. So that is how you're going to use laws. Let us take one more example to understand the use of laws. This is an MCQ here. And what are we going to do is we are going to simplify and find out which option it matches to. Okay. So negation of A implies B is logically equivalent to A and negation B, right? Yes. This we have done while doing the negation of compound statements. So if anybody asks me what is negation of P and Q implies Q, it comes out as P and Q and P and Q and negation Q. Okay, so negation of A implies B is A and negation B. So negation of P and Q implies Q is P and Q and negation Q. This will copy as it is. P and Q will copy as it is, and there will be negation Q. And then once that is done, you can now say andar or bahar, the signs are same. And if the signs are same, I have taught you something called as associative law. So let me associate Q and negation Q. Let me associate this Q with negation Q. So what law I'm going to use is associative law. Okay. And after that, you see there is Q and negation Q. Q and negation Q. So Q and negation Q, you can say it is complement law. And here you're going to get contradiction, because if true, this will be false. True and false, false. If this is false, this will be true. False and true will be again false. What law we're going to use is complement law here. And as I said, after complement law, you will have to use identity law. And identity laws says here, this is contradiction, because you take true, true and false will be false. You take false, false and false will be false, right? Yes. So the answer is in this case always false. They have written F there, but it should be contradiction, which is always a false statement. So whatever be the input, whatever be the input, the output is always false. The last one which I have done is by which law? Identity law. You have to always write the laws. Okay. We can also, as I said, this I'm using laws right now here, but we can also always show this using truth table. Okay, so let me make a truth table at this side in the CT pattern. What I'll do is I want to find out negation of, we're going to make a truth table, and for that I want to find out negation of P and Q. I remember the result, it is true, false, false, false. Implies, how do we write Q in the table? It is true, false, true, false. Okay, true false false implies true false true false. So this is going to be negation of. True implies true is true. Only in one case we get false. That is when true implies false is false. In all the other cases, it is going to be true only. So I got true implies true, true. Right? But then you see, it is false. But false implies anything is true. Only in one case you get false is. True implies false is false. Only in one case. Again I repeat, only true implies false is false. In all the other cases you're going to get true. So false implies false, true. False implies true also is true. False implies false, again we have true. So I get negation of this and it is false, 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 false. Contradiction. Okay, so always you can do this using truth table, no doubt, but I have done first using the statements. Right, first we take the negation, then we use the associative law, then I got complement law, say contradiction here, and then P and contradiction is contradiction, and then the side I'm showing you the truth table. Okay. So this is the second example which I have showed using laws also, and then I have showed the truth table of it. You can do it using truth table too.